Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now people just let me know on the chat if you can hear my voice clearly. And then we are starting with this live stream of O-level maths. And the focus is on graphical solution of equations. So let's get started. Now, first of all, when you look at the new syllabus, it started from last year. So there is the section 2.10. This is about graphs of function. And it is about all these things: construct table of values, draw, recognize, interpret graphs of these types. Ax power n. X could be power 3, x could be power 1, and then negative 2. It could be a reciprocal function and things like that. And these n could be negative 2, negative 1, negative half, 0, half, 1, 2, 3. And then solve associated equations graphically, including finding and interpreting roots by graphical method. That is one thing. And then draw and interpret graphs representing exponential growth and decay problems and estimate gradient of curves. So now all this thing, this is about graphs. This is about drawing. This is about manipulation, algebraic manipulation, that is. This is about slopes, gradient. This is about intersection of line and a graph, line and a curve. And then it is also about some types of interpretation. So interpretation, and this one is intersection. Do not mix the two. So, and this is, of course, done on graph paper. And what else is there? This is about a table of values. There is X, there is Y, there is table, and you use a calculator. So this is one aspect of it. The other aspect is this one, which is about the algebra and graphs continued. This is 2.11. This is sketching. So sketch is just using the main idea without graph paper, without table of values, and maybe you take care of, let's say, slope, y-intercept, you take care of turning points, you take care of roots, you take care of asymptotes, and things like that. And based upon that, you sketch it. So now it says recognize, sketch, and interpret. That is the three main idea: recognize, sketch, and interpret graphs of the following. Linear. So they have written linear as this, which is ax plus by is equals to c. Of course, we can manipulate it and write in the form y is equals to mx plus c. Then we have quadratic. So the quadratic, they have written it over here. The blue one is the quadratic. Then cubic, they have written two types of cubic, these two, this one as well as this one. And we will go over every single one of them. And then they talk about reciprocal. So this is the reciprocal that they talk about. And the last one, that is exponential. And this is the exponential thing that they talk about. So these are the different ones. So the red one is linear. The blue one is quadratic. The green one is cubic. Two formats of cubic. Reciprocal is this one. Exponential is this one. Now, what are we interested in? We are interested in knowledge of turning points, vertical and horizontal asymptotes, roots, and symmetry is required. Finding turning points of quadratics by completing the square method may be required. Now, maybe means yes, it is required. So now let's get started with the basic idea. The very first thing, that is sketching the linear function. Now, when we talk about the linear function, we talk about y is equals to mx plus c. Everyone knows this. X and Y are variable. This M is the slope and C is the y-intercept. So M is slope and C is y-intercept, where the line cuts the y-axis. That means X coordinate is 0. Slope can be positive, slope can be 0, slope can be negative, slope can also be undefined. Now let's first talk about how can a slope be positive. Now let me just fit in two more sketches over here like this. And look over here. When we say slope is positive, that means the line is going up like this. That is a positive slope. Negative slope is something like this. So this is positive slope. This is negative slope. Yes, we have to go to the very, very basic, because when the examiner asks these questions for 100 marks and 100 marks, so it's not always a table of values. It's a concept. You have to recognize it. Positive slope, negative slope. Now, positive means when X increases, Y increases, like direct proportionality. Negative slope means when X increases, Y decreases. X increases, Y decreases, and so on. Now, some of you or they can comment on this live session. That's one thing. The others, they can also comment on the WhatsApp group that I have, so I can know exactly who is joining in. And now over here, positive slope, negative slope. What about a zero slope? A zero slope is like this. Zero slope means change in y is 0. That means line is parallel to x-axis. So zero slope, therefore gradient is 0. And when we talk about undefined slope, that means change in x is 0. Therefore, line is parallel to y-axis. And this is undefined slope. So that means a line can only have 4 possibilities: positive slope, red line; negative slope, blue line; zero slope, green line; undefined slope, that is this. Now, let's move on. If they ask me to draw sketch, so this is all about sketching for right now. So we are doing sketching first, and then we will move to the graph. Y is equals to 2x plus 1. Let me write y is equals to negative, or let me write 3x minus 4. What is common between the two? The common thing is the slope is positive. The slope is positive. And this y-intercept is positive. This y-intercept is negative. So slope is positive. Y-intercept is positive. Slope is positive. Y-intercept is negative, but make sure of one thing, that is y on the left-hand side. And coefficient of y is 1. Therefore, it's of the form y is equals to mx plus c. Very, very basic stuff. So now draw a line with a positive slope and a positive y-intercept, something like this, which makes perfect sense. Let's say this is 1 and the slope is positive. All good? All clear? Let me thin out this line a bit. Now, positive slope, negative y-intercept. So this is positive slope and negative y-intercept, which is negative 4. That's how we get it. Now, some people, they ask this question. We focus on y-intercept. Why don't we focus on x-intercept? Because it's not part of the equation. Y is equals to mx plus c. This is the y-intercept. Whenever we talk about y-intercept, That means x is 0. It could be about a line cutting the y-axis or a curve cutting the y-axis. Similarly, when we talk about x-intercept, let me just decrease the brightness. That means y is equals to 0. So always remember, y-intercept, x is 0. X-intercept, y is 0. Coming back to this, we are only interested in gradient, y-intercept, gradient, y-intercept. Now let me write over here, x plus y minus 3 is equals to 0. So do not decide on anything unless and until you have made y the subject. So y is equals to minus x plus 3. Now y is all alone on the left hand side with a coefficient of 1. And now over here, the slope over here, that is negative 1. So therefore, the slope is negative 1. And yes, it's negative, and y-intercept is positive 3. So you can write the value, you can simply write the sign. And that's how the line is going like this. So that is a negative slope and the positive y-intercept, which is 3. Similarly, if I have y is equals to negative half x and negative 4. So now again, the coefficient is negative and the y-intercept is also negative. So the gradient is negative and the y-intercept is also negative. So now the line goes like this, something like this. Got the idea? So now just acknowledge, is this the concept of linear expression all good, all clear? We will go over 2-3 things and then we will try out past paper questions later on. So now let's talk about quadratics. Yes, this does take time. There are 3 formats of quadratic. They have just written the general form, that is this. But actually there are 3 of them. Y is equals to ax square plus bx plus c. This is called the general form. Then we have y is equals to ax minus p x minus q. That is the factorized form. And then we have y is equals to ax minus h whole square plus k. That is the completed square form or the form that you get after completing the square. So completed square form. So these are 3 formats. We need all 3 of them. Everyone has its own benefits. This is written for middle term factorization. This is used for quadratic formula. So that is the original one. Factorized form, this can be used for sketching. This can be used for finding the roots. And the shape thing is common in all. So A tells us about the shape. If A is positive, the shape is like this. If A is negative, the shape is like this. This is a happy face. And this is a sad face. So now let me just change these two and change it to something like this. So this is happy face. This is sad face. This is the color. This is the combination I'll use. So A tells you the shape. A is the same all over. So sketch and roots. Yes, these are the 2 things. Completed square form. What are we interested in? Again, that is from the perspective of sketch and from the perspective of turning point. So that is what we use it for. Now, if I talk about the basic graph, let me draw this thing, a quadratic like this. Okay. And let me just paste it over here. That is the first one. That is the quadratic. And let me just copy it. And let me add it as an element. Okay, so this is a new collection and this is curve. Okay, that's the first one. And let me draw another one, or let me just take this thing, copy, and let me change the color to blue and let me flip it. And let me make it a little bit bigger. Okay, so now that goes over here. And let me also add it as an element in this thing. Okay, so now the red one, that is the original graph. That is y is equals to x square. Coefficient of x square is positive. Therefore, it's a happy phase graph. And yes, it has a minimum point. That minimum point is the origin, 0, 0, because it does not go anything below this. Y is equals to negative x square. The coefficient of x square is negative. That is why this is a sad phase graph. And instead of minimum, it has a maximum point. And this maximum point is 0, 0. That is 0, 0. That is the basic idea. So minimum point, maximum point, and let's now play with this. If I want to compare y, if I want to draw y is equals to 2x square, and if I want to draw y is equals to half x square, because sometimes they ask you this. So what we can do is that we can, no, I did not want this thing. Hold for a second. For some reason, we have this. So that is the original one, y is equals to x square. And let me draw something more steeper. That is the green one. And it becomes more steeper like this. So that is the green one. That is y is equals to 2x square. So it becomes more steeper towards y-axis. That is just a basic idea. For our purposes, it looks the same. Y is equals to half x square. So let me copy this thing. This one. Let me paste it over here. And half x square, this will become flatter, something like this. Okay. So now this is half x square, that is more flatter towards x-axis. That is the basic idea. So it's the shape is almost the same. One is more steeper, the other one is more flatter. Now, if I talk about y is equals to x square plus 1, y is equals to x square plus 1. So now the curve will be shifted up by 1 unit. So if it's shifted up, let me copy, let me paste, let me change the color to green. And this original one is shifted up by 1 unit like this. So therefore, this point over here is 0, 1. So 0, 0 becomes 0, 1. That's a basic transformation. Something like this. And if it is y is equals to x square minus 2. So let me paste it, change the color. It will be over here and it will be shifted 1 unit, 2 units down, something like this. So the purple one, that is y, is the curve is shifted down by 2 units. So what happens to the turning point? The 0, 0 will now become what? 0 and negative 2. So let's recap what we have done so far. The original red one, the reflection in x-axis. This gets reflected in x-axis. That goes like this. That is happy face. This is sad face. Happy face gets thinned out when we have a number like 2, 3, and so on. When we have a small fraction between 0 and 1, it gets flattened out. This is shifting up. This is shifting down. That's the basic idea. Now, let me explain over here. This is all based on the original form, the general form. Now, if I talk about the factorized form, factorization includes taking common. Factorization includes middle term factorization. Factorization also includes this thing, which is difference of two squares. So now, when we talk about this thing, what does factorization includes? So now it includes the following: taking common, middle term factorization, and difference of two squares. For example, x squared plus 4x. I can take x common, x plus 4. This is taking common. So that is the first one, taking common. That is an example right over here. Something to do with middle term factorization. So something like x squared minus 5x plus 6. That is x squared negative 2x negative 3x plus 6. That is x bracket x minus 2 minus 3 bracket x minus 2. X minus 2 is taken common, and then x minus 3. So now this thing over here, this is middle term factorization. We all are aware of it. And then we talk about this thing, which is called difference of two squares. We know that a square minus b square, that is a plus b, a minus b. This is called difference of two squares. So therefore, x square minus 4, this is basically x squared minus 2 square, which is x plus 2, x minus 2. X squared minus 25, that is x squared minus 5 squared. This is x plus 5, x minus 5. 4x squared minus 9 can be written as 2x the whole thing squared minus 3 whole thing squared. That is 2x plus 3, 2x minus 3. So these are the examples of this. Now, can I sketch these? The answer is yes. Y is equals to a, x minus p, x minus q. A, that is the coefficient of x squared, because this x is positive, this x is positive. So that would determine on the outside. If a is positive, that's the shape. If a is negative, that's the shape. And when y is equals to 0, you get x-intercepts. They are also called the roots of equation. And this is x minus p equals to 0, x is p, x minus q equals to 0, x is q. These are the roots of the equation. So now if I take this first example, x bracket x plus 4. So let's take the first example, which is x bracket x plus 4. So this is x bracket x plus 4. And let me equate it to y. So now the focus is, this is x is positive, coefficient of x squared is positive, therefore the shape is like this. And then make y is equals to 0, therefore x bracket x plus 4 equals to 0, therefore x is 0, x is negative 4. These are the roots. So all you do is this thing, you draw a sketch. That is a simple x-axis, there is a simple y-axis, and draw the curve in such a manner that it passes through 2 points. And those 2 points are what? This is 0 and this is actually negative 4. So let me just do one thing, and that is very cheeky. That is, take this and put it over here. And this thing is gone. So therefore, this is negative 4 and this is 0. That's how the sketch is drawn. This is y, this is x. So now Someone is saying आवाज हल्की आ रही है. I think it's just an issue. Let me just check. I think it's all good from my side. It's perfect. I think maybe your net connection is weak. So yes, people, that can happen. You can watch the recording later. So now this thing is there. And let me also check one thing on the WhatsApp. So now let me write it out. Okay. So now that is how you draw it based upon this. So this is the factorized form. Now let's say we have this thing, x squared minus 5x plus 6. Let me draw it over here. Y is equals to x squared minus 5x plus 6. We have already done the factorization. That is x minus 2, x minus 3. Now again, yes, there is a 1 written on the outside, but also look on the inside. That is positive, positive. So coefficient of x squared is positive. That's good. And the roots you can either get by comparing coefficient or just do it visually. X minus 2 equals to 0, x is 2, x minus 3 equals to 0, x is 3. So now let me draw the small thing like this. The thickness and all these things doesn't matter. This is just a sketch. And this is 2, this is 3. The shape is all good. Something like y is equals to 4x squared minus 9. That is 2x plus 3, 2x minus 3. And what else is over here? Again, focus on this. The coefficient of x squared is positive. And when I talk about the roots, 2x minus 3 equals to 0, x is 3 over 2, and x is negative 3 over 2. So let's draw it. Just a curve like this. Let me make it thinner. Okay. Now let me take this, fit it over here. Okay. So now over here, we have this thing. This is negative 3 over 2. This is positive 3 over 2. And let me draw one more. Y is equals to 9 minus x squared. That is 3 squared minus x squared. That is 3 plus x, 3 minus x. So now over here, when I look on the outside, it's all peaceful. When I look on the outside, it's just a 1 over here. So do not decide on this. Decide on this. This is positive x. This is negative x. Therefore, coefficient of x squared is negative. And when we talk about the roots, 3 plus x equals to 0. X is negative 3. 3 minus x equals to 0. X is 3. So now draw it upside down like this and just shift it a bit, something like this. And therefore, this is negative 3. This is positive 3. So these are all the examples of the factorized form. Now let's focus on one thing. That is, quadratic curves are symmetrical. So let me write over here, quadratic curves are symmetrical about something, about turning point. So let me focus over here. This line is the line of symmetry. So let me draw this thing. This is the line of symmetry. Over here, the y-axis is the line of symmetry. Over here, y-axis. Over here, y-axis. So in a simple graph in which you are kind of steepening it or flattening it or moving up or down, y-axis is the line of symmetry. Again, this is also y-axis is the line of symmetry. This y-axis is the line of symmetry. But when we are talking about these things, now the line of symmetry is something else. Now the line of symmetry is this line. Let me choose this color, but let me lighten it. I think Okay, this looks better. So now this is the line of symmetry. Over here, this is the line of symmetry. It's not exact. It's not a scale diagram. Over here, this is the line of symmetry. Over here, this is the line of symmetry, and so on. Now let's focus. We also see that this is -2. This is -4. This is 0. Therefore, x coordinate of turning point lies midway between the roots. Got the idea? So x coordinate of turning point is half the roots -4 plus 0, that is -2, which makes sense. So this vertical line is x is equals to -2. Yes, I need to go back a bit, and that is in the linear thing, that when we are drawing a line and the line is parallel to x-axis, line parallel to x-axis, gradient is 0. So y is equals to mx plus c becomes y is equals to c. All along the line, y coordinate is unchanged. So therefore, let's say this is 2. So this is, for a second, let's say this is -5 and 2, this is 0 and 2, this is 3 and 2, and so on. So therefore, the equation of the line is y is equals to 2. That's the y-intercept. Similarly, if we have a line like this, line parallel to y-axis, gradient is undefined. You cannot define it. Therefore, the equation is x is equals to a, because all along the line, the x coordinate is unchanged. So if this is 3, then the line is x is equals to 3. So keep this in mind. One other thing, that is, this one is the y-axis. This one is the x-axis. So equation of x-axis is y is equals to 0, because all along the line, y coordinate is 0. Equation of y-axis is what? Is x is equals to 0. So now coming back to this. So the basic quadratics, then the factorized form, then the sketches of this factorized form. Over here, x coordinate of turning point, that is half between 2 and 3, which is 2.5. So the equation of this line is x is 2.5. Over here, -3/2 plus 3/2, add them, divided by 2, that is x coordinate of turning point. X coordinate of turning point is 0. So therefore, x is equals to 0. That's the line of symmetry. Again, x is equals to 0. That's the line of symmetry. So x is equals to x coordinate of turning point. That is the line of symmetry. So now people are just okay. Is it all good? Like 2 people have done over here, and this is all good, all clear. So far, quadratics, the main thing is done. Now let me move to the idea of completing the square method. So now this is completing the square method. First, let's sketch it. So first, if we sketch it, this is y is equals to ax minus h whole square plus k. So there is this thing which is a, and then compare it with -h, and then there is a plus k. So therefore, this a, if it's positive, that's the shape. If it's negative, that's the shape. And h comma k, that is the coordinate of the turning point. If they ask you for the roots, then y is equals to 0. But right now, we are just interested in this. Every format has its own limitation. So now over here, what we do is that we have to make use of this by drawing. Let's say I have y is equals to x minus 1 whole square plus k, actually 4. And over here, let me write y is equals to x plus 2 whole square plus 3, something like this. What we will do is that underneath it, we will write y is equals to a x minus h whole square plus k. Now keep in mind, this is a gold standard. Just like y is equals to mx plus c is a gold standard. So if the examiner plays around with this negative sign, with this positive sign, don't fall into the trap. So now over here, if I compare, there is a 1 over here. So a is 1, which is positive. That's the shape. Minus h is minus 1. Therefore, h is 1. And k is 4. Therefore, 1 comma 4 is the coordinate of the turning point. So this time you are interested in the shape and in the turning point. And that is how it looks. So it's not an exact diagram, but whatever we can do. So this is 1, this is 4, and that's how the curve looks like. Similarly, over here, underneath it, write it, y is equals to a x minus h whole square plus k. So hold for a second. A is 1, positive. That's the shape. Minus h is plus 2. So h is negative 2. And k is positive 3. So negative 2 comma 3, that's the coordinate of the turning point. So let me draw this thing like this. And this is this thing. That is negative 2. That is positive 3. That's how the graph looks like. Something like y is equals to minus 2 x minus 1 whole square minus 5, actually plus 5. Underneath it, right? This is a x minus h whole square plus k. A is negative. The shape is like this. Minus h is minus 1, therefore h is 1, k is 5. So 1 comma 5 is the coordinate of the turning point. And now the graph goes like this. Why it goes like this? Because it is upside down. So this is 1, this is 5. That's the turning point. And of course, if you are interested about the line of symmetry, there it is. If you are interested about the line of symmetry, the turning point is still there. Got the idea? So that's how the graph will look like. And let me draw once more. Y is equals to negative 3 x plus 1 whole square minus 2. And this is a x minus h whole square plus k. Therefore, a is negative 3 upside down, minus h is 1, h is negative 1, k is negative 2. So now negative 1, negative 2, this is negative 1, this is negative 2, like this and like this. So therefore, the graph goes like this. Let me draw it like this. Okay. So now this is negative 1, negative 2. So this is negative 1. This is negative 2, and it's gone like this. So completed square sketching is also done. Now, how to do the completing square method? That is important. The how to do completing the square method. Now, there is a background story of this, but I think near the exam, it's not worth it going over that story. So let me tell you the very, very shortcut. The first thing, make sure coefficient of x square is 1. If not, take common throughout. I'll show you all these steps. The next one, that is the ax square, the bx, put it on the left-hand side. Constant, put it push it to the right hand side, and in between, first add, then subtract square of square, don't forget the square of half the coefficient of x. And then the third step, rewrite first three terms as a perfect square algebraic expression and simplify the rest. Now, this is too much of English for you people, right? So let me simplify it, how to do it. So this is how. Make sure coefficient of x squared is 1. If not, take common throughout. Take a screenshot so that you can refer to it. And now I'm back. It was getting a bit chilly. So now make sure coefficient of x squared is 1. If not, take common throughout. Push the two terms on the left, push the constant on the right. First add, then subtract square of half the coefficient of x, square of half the coefficient of x. Rewrite the first three terms as a perfect square and simplify the rest. Now let me show it to you. 3 or 4 examples would be enough. So first of all, black marker, worked example 1. I have y is equals to x squared plus 4x plus 10. Step number 1. Is the coefficient of x squared 1? Yes, it is. So nothing to worry. Second step, x squared plus 4x, push the 10 to the right hand side. First add, then subtract square of half the coefficient of x, coefficient only. Coefficient of x is 4, half of it is 2. Now, from your knowledge of O-level maths, we know that a plus b whole square is a square plus 2ab plus b square, correct? So let me write over here. I know that a plus b whole square is a square plus 2ab plus b square, and a minus b whole square, that is a square minus 2ab plus b square. So focus on this. If there is a plus sign, the middle term is positive. If there is a negative sign, the middle term is negative. And basically, you pick the A, put it over here. You pick the B, put it over here. You pick the A, put it over here. You pick the B, put it over here. So you have to compress. So now going this way, this is expansion. And this is compression, factorization. So let me compress it. This is x squared. This is 2 squared. This is positive. So basically, this is x plus 2 whole square. I hope you all agree. And I'll be doing some examples. So don't worry. If one class is not enough, I'll take another class of the sketches. I'll finish some part today, some part tomorrow, but I won't hurry because the main objective is for the masses to understand it thoroughly, the Shahab Yaqub's way. So now over here, this thing is all used up. This 3 is this. This is minus 4 plus 10. 10 minus 4 is 6. That is x plus 2 whole square plus 6. Now it's of the completed square form. Basically, you had a square, x square, you had an x. You kind of trap it inside a bracket. Now if I compare, this is a x minus h whole square plus k. So we are not sketching it, just writing it down. A is positive. You don't need the value, just the shape. Minus h is 2, so h is negative 2. K is 6, so minus 2 comma 6. That's the coordinate of the turning point. So all good, all clear. So I think it's difficult writing this thing. Okay. So now that's how we do it. That is the first worked example. Now let me do the second worked example. So second worked example is y is equals to 2x squared plus 12x plus 14. And now Let me take 2 common out. So now the coefficient of x squared is not 1. So if I take 2 common out throughout, there are two different schools of thought. Some people take common from the first two terms. I believe in justice, taking common throughout. X squared plus 6x plus 7. And instead of 14, hold for a second, let me write something different, 20. And this becomes 10. Now repeat the same process on the inside. 2 is waiting on the outside. That is x squared plus 6x plus bracket square minus bracket square plus 10. What goes inside the bracket? Half the coefficient of x, which is 3, which is 3. Now we know that this is basically x squared. This is 3 squared. This is positive. So this is x plus 3 whole square. And the 2 is still waiting on the outside. X plus 3 whole square minus 9 plus 10. And this is 2x plus 3 whole square plus 1. Now open it up. And this 2 gets multiplied with this and this. Some people, they miss it out. That is 2x plus 3 whole square plus 2. Now this is of the form ax minus h whole square plus k. So a is positive, that's the shape. H is negative 3 and k is 2. So negative 3 comma 2, that's the coordinate of the turning point. One other thing, maybe life is full of fractions. What if I have y is equals to 3x squared plus 9x plus, let me make it 21. Let's take 3 common out. This is, and let me change one of the sign just to be. So 3 common, that is x squared plus 3x minus 7. This is the same thing, 3 common, x squared plus 3x plus bracket square minus bracket square minus 7. What goes inside the bracket? That is half the coefficient of 3. So work in fractions always. Doesn't make a difference whether it's P1 or P3 in such a P1 or P2. In such a situation, always work in fractions because fractions are exact. Fractions are exact. Fractions are supreme. They have an edge over decimals. And fractions are beautiful because you don't have to worry about the accuracy thing. So now what happens to these three? So this is x, this is 3 over 2, middle term is positive. I'll also do one with a negative sign. X plus 3 over 2 whole square. And this 3 is still on the outside. This is negative 9 over 4 minus 7. Now open it up. So that is 3x plus 3 over 2 whole square minus 27 over 4. 3 into 7 is 21. That is 3x minus x plus 3 over 2 whole square. 4 into 21 is 84 and 84 plus 27, whatever that is, 84 plus 27 divided by 4, that is the answer. All good, all clear? So I need one more example, worked example 4. Something like y is equals to negative x squared plus 2x plus 5. Now negative 1, you need to take common. So you need only positive 1. So therefore you will take negative 1 common. That is x squared minus 2x minus 5. That is negative 1 common. It's better to write a 1. That is x squared minus 2x plus bracket square minus bracket square minus 5. What goes inside the bracket? Negative 1, negative 1. Now keep in mind, if this thing is negative, of course, that makes the inside negative. So you don't have to write negative twice. You don't have to cancel it. It simply means it's of the format a minus b whole square, x minus 1 whole square. And then this is minus 1 minus 5. Open it up. That is minus x minus 1 whole square plus 1 plus 5. That is negative x minus 1 whole square plus 2. That is how the completed square form is done. So we did a lot of things over here. Let's move to cubic. So now we have done quadratics, all the types. We have done linear function. It's time for cubic. Now in cubic, they have given us two formats. One format is this thing, y is equals to this thing. I don't know why is it not pressing. Y is equals to ax cubed plus t, the basic plus minus. And this is the one in which there is x and x and x, something like this. So we need to understand both very, very thoroughly. When we talk about the first thing, why is it all blank pages over here? So let's get started with this. Let me first draw this thing. And then this thing over here, like this. Versus the blue one, that is this and this. Now, yes, I can explain something over here. That was when we talk about squaring, positive 2 whole square, that is 4. Negative 2 whole square, that is also 4. That's why square root of 4 could be positive negative 2. Got the idea? And when we look at it from the perspective of sketch, so we know this, that the graph goes like this. The reason why it is like this is that when x is 2, y is 4. When x is negative 2, y is still 4. So now over here, this is, let's say this is 4. So 4 was obtained from 2, 4 was obtained from negative 2. Got the idea? And yes, over here, that's how it looks like. When we talk about cubing, minus first plus 2 whole cube, that is 8. Minus 2 whole cube is negative 8. It's not plus 8. Therefore, cube root of 8 is only 2. Cube root of 8 with a negative sign is negative 2. So cube root exists for a positive value. You can take cube root of a positive as well as negative value. But when we talk about square root, let me just push it down. When we talk about a square root, so can only take square root of a positive value. Got it? So now over here, this red one, that is the graph of y is equals to x cube. When x is positive, y is positive because y is x cube. When x is negative, y is negative, which makes sense. When x is positive, y is positive. When x is negative, y is negative. So it starts from top right, TR, and it goes till bottom left. Or you can say like this and like this. Top right, bottom left, top right. Y is equals to negative of x cube. This is top left. This is bottom right. Like this, like this. Why? Because when x is positive, y is negative. When x is negative, y is positive. How come? If I take 2, I cube it, that is 8. But because of the minus sign, it's negative 8. So x is positive, y is negative. X is negative, y is positive. That's the two basic ones. Okay, so now over here, if I write it like this, y is equals to x cubed plus 1. So x cubed plus 1 is draw that x cubed and shift it up by 1 unit. So that goes like this and like this. So now the turning point, which was 0, 0, is now 0, comma 1. The turning point over here is 0, 0, but it's neither a max nor a min. This is 0, 0. So the origin is a turning point. This origin is also a turning point. TP stands for turning point. And now the turning point is 0, comma 1 because we have shifted it up by 1 unit. What if I want to draw y is equals to x cubed minus 2? So x cubed minus 2, let me draw it like this, something like this, and like this. So now this is 0 and negative 2. So let me write the 2 properly. So now the turning point is 0 and negative 2. It has shifted down. If I want to draw y is equals to negative x cubed plus 1. So negative x cubed plus 1, grab that blue marker like this and a thicker one. And let me also draw one other one. Okay. So now this is y is equals to x cubed plus negative x cubed plus 1. So therefore, this is 0, 1. And this is y is equals to negative x cubed negative 3. So this is 0 and negative 3. So now these four graphs that I have drawn, they are of this type. Let me just remove this one blank page from here. They are of this type. That is ax cubed plus d. So they are of the type, this is y is equals to ax cubed plus d. A just changes the steepness. So this is a is positive. Doesn't make a difference. It's 1 or 2 or 1,000. Over here, a is negative. A is the coefficient of x cubed. If the coefficient of x cubed is positive, then it's top right till bottom left. If the coefficient of x cubed is negative, this is top left till bottom right. Have a good look at it. Okay. So now that's how this thing is drawn. Take a screenshot if you want to. And those people who are in my WhatsApp group, of course, they can also receive the PDF. So now this thing is done. This is x cubed plus 1. This is of the same type, ax cubed plus t. So now this is y is equals to ax cubed plus t. If this d is positive, it goes up. If this d is negative, it goes down. Got the idea? This is the same thing, except that there is a negative sign, and then it's moving up and then moving down. That's the basic idea. Now, what can we do? Now, let me talk about something like this. Y is equals to x squared minus 5x plus 6 that I used, that is x cubed minus 5x squared plus 6x. Let's say I have a cubic equation like this. And if I take x common out, this is x squared minus 5x plus 6. And I can break up the inside. That is x squared minus 5x, x squared minus 2x minus 3x plus 6. That is x squared, x minus 2, minus 3x minus 2, And then we know that these two are the same. That is why it's taken as common. So this is x on the outside, this is x minus 2, and then this is x minus 3, like this. And we get the factorized form, that is x minus 2, x minus 3. Now, look at the coefficient of x cubed. X is positive, x is positive, x is positive, x was already positive. So coefficient of x cubed is positive. Therefore, this is top right till bottom left. And now the additional thing, that is the roots. That means x-intercepts. That means y is equals to 0. So x bracket x minus 2, x minus 3 equals to 0. Therefore, x is 0. X minus 2 equals to 0. X is 2. X minus 3 equals to 0. X is 3. So you get three roots. Root, root, root. So now based upon these roots, I can sketch. So now I have the ability to sketch a cubic function based upon shape and based upon roots. And this is part of the syllabus that is right over here, which is this. Ax cubed plus bx squared plus cx, there is no constant. That you study in A levels. So now over here, this is of the form y is equals to ax cubed plus bx squared plus cx, which is basically x, ax squared plus bx plus c. So when this is the scenario, always one of the root in such a situation will be 0. That will be based upon this thing. And the other two roots are hidden on the inside. Now, if I want to draw x minus 2, x minus 3. So this is y is equals to x minus 2, x minus 3. The shape is top right till bottom left because coefficient of x cubed is positive. And then the next thing, the roots, we already calculated. X is 0, x is 2, x is 3. So now, let's draw it. And let me choose a thicker marker. So red one. No, my bad. Like this. It has to pass through 0. It has to pass through 2. It has to pass through 3. It's not drawn to scale. This is top right. This is bottom left. So the cubic looks amazing. I hope everyone agrees with this as long as they understood it. So that is y is equals to something of this form. Got the idea? So now let me draw another one. Now I'm already factorizing it for you. Y is equals to x plus 1, x minus 4. So now over here, again, x is positive, x is positive, x is positive. Coefficient of x cubed is positive. That's the first thing. That means top right, bottom left. And then the roots, y is equals to 0, x is 0, x is negative 1, x is positive 4. So now a positive 4, negative 1, and 0. So positive 4, 0, and negative 1. That's how it looks. This is 4. Of course, the diagram is not drawn to scale. So this is 0. This is negative. Top right, bottom left. What if it is something like this? Y is equals to x, and this is 1 minus x, and x plus 2. Now, this x is positive, but this x is negative. This x is positive. So coefficient of x cubed is negative, top left till bottom right. The next thing is the roots. That is y is equals to 0. So therefore, x is 0, x is 1, x is -2. Double check. A lot of people, they make a mistake. 1 minus x is equals to 0, x is 1. X plus 2 equals to 0, x is -2. So now the thick marker, there is 0, there is 1 over here, there is -2 over here, something like this. And now it's coming this way, like this. Let me first draw it. It looks weird to me. This is better. This is 1. This is 0. This is -2. This is top left. This is bottom right. What about y is equals to x bracket, and let me write x square minus 16. Maybe originally it was written as this, that is x cube minus 16x. So I took x common, x square minus 16. That is x common. And this is x plus 4, x minus 4. So now again, coefficient of x cube is positive, x is positive, x is positive, x is positive. So top right, bottom left, and then the roots. That is y is equals to 0. So x is 0, x is -4, x is positive 4, and it should be symmetrical. And that's how it goes. This is positive 4. This is 0. This is -4, top right, bottom left, because the coefficient of x cube is positive. So now this thing is all done and dusted. The cubic thing. Yes, let's look at this. We are focusing on this. One of the new things in the syllabus, that is expand and simplify. So now it's your choice how to multiply it out. I'll just keep the first bracket intact and then multiply the other two. 4x into x, that is 4x squared. 4x into -5, -20x. 1 into x is x, and this is -5. Now it says expand and simplify. That means don't leave it as it is. Expand it fully. So this is x minus 2. This is 4x squared minus 19x minus 5. Now the numbers sometimes look weird, so no harm in double checking. 4 into 1, that's 4x squared. 4 into -5, -20x. 1 into x, positive x. 1 into -5, -5. -20 plus 1, -19. This is 4, this is -5. Now multiply with the x. X into 4x squared, that is 4x cubed. That is 19x squared. That is -5x. And then minus 8x squared. I have a habit of writing it like this. And then minus minus, that is positive, that is 38x, and minus, that is also positive, that is 10. Now add it up. This is 4x cubed, 19 plus 8, that is 27 with a negative sign. 38 and 5, the difference is 33 with a positive sign, plus 10. So always make a habit of writing it down. That is 4x cubed minus 27x squared plus 33x plus 10. That is how this answer looks like. All good, all clear. This is simply expand and simplify. Now, another past paper question. It says 2x cubed minus 3x squared minus 20x. Now you have to factorize. So take x common out. That is 2x squared minus 3x minus 20. Middle term factorization, that is 2x squared. That is 8 and 5. So negative 8x plus 5x minus 20. That is x. That is 2x minus 4 plus 5x minus 4. This is x bracket x minus 4 and 2x plus 5. So this is x, x minus 4 and 2x plus 5. Now keep in mind one thing which people forget. It simply says factorize. It's not an equation. So therefore, do not equate to 0. At this point, it's not an equation, it's just an expression. Keep that in mind. Sketch this graph. So now when I'm sketching this graph, this is y is equals to x bracket x minus 4 to x plus 5. That is what I just taught you. The first thing, that is positive, positive, positive. So coefficient of x cubed is positive. All good? Top right, bottom left. Next thing are the roots. Let me write it below so that it does not mess up my beautiful graph. So roots, x is equals to 0, x minus 4 equals to 0, x is 4, 2x plus 5. So x is negative 5 over 2. So there is 0, there is negative, there is positive, and let's get started. So somewhere over here, like this. And let me just make it thinner. I think this is beautiful. This is negative 5 over 2. This is 0. This is positive 4. Top right, bottom left, and you are all set. This thing is done. Again, expand and simplify, nothing special. This is an IGCSE paper. So this one is not for you. This is out of syllabus. Let's focus on this. It says for each sketch, put a ring around the correct type of function shown. This is a cubic, linear, cubic, quadratic, reciprocal, exponential. So yes, this is cubic, and that is the right one. That is part. The next one we haven't studied as yet, but this one is reciprocal. That is the inverse proportionality function. For right now, I've just labeled it. I think this is also IGCSE. This thing is equivalent to this. Find the value of each A, B, and C. So yes, the examiner can very well ask you, the Cambridge examiner, O-level examiner, and the IGCSE examiner, they're always in contact. They copy from one another. They steal each other ideas. Expand this thing. That is x plus a. That is x plus 2. That is 2x plus 3. And then compare coefficient. So now x plus a, let it remain as it is. First multiply these two, x into 2x, that is 2x squared. X into 3, that is 3x, 2 into 2, that is 4x, 2 into 3, that is 6. Simplify once again on the inside, 2x squared plus 7x plus 6. And this is x plus a. X into 2x squared, that is 2x cubed, 7x squared. This is 6x, a into 2, that is 2a, x squared, and that is 7ax, and that is 6a. And add it up. This is 2x cubed, x squared, that is 7 plus 2a. You can write it in the opposite order also. Let me write it because people might be getting confused. So this is 7 plus 2a, that's the coefficient of x squared. This is 6 plus 7a, that's the coefficient of x, and the constant term is 6a. Underneath it, write this 2x cubed, 2b, c, and negative 18. 2b, c, and negative 18. Now, when I compare each one, the first one, this 2 and 2 are the same. Nothing to do over here. This one, 7 plus 2a is equals to b. So 7 plus 2a is equals to b. Leave this equation on the sidelines. Third, 6 plus 7a is c. So 6 plus 7a is equals to c. That is the second. And the last one, 6a is negative 18. 6a is negative 18. That is equation 3. Therefore, a is negative 3. So if I plug in the first one, 7 plus 2a, 7 plus 2 times negative 3 is equals to b. 7 minus 6 is b. Therefore, b comes out to be 1. So b comes out to be 1. Similarly, over here, 6 plus 7 times negative 3, that is equals to 6 plus 7a is equals to c. That is 6 minus 21 is equals to c. So c comes out to be negative 15. C comes out to be negative 15. And the value of a was negative 3. So that is also a nice question. Take a screenshot if you want to. And of course, you can take the screenshot a little bit later also. So I think we have done lots of things. And another question of the same type, we can do it like this. Show that the equation can be written as this and sketch the graph of this. So let me just sketch the graph. The multiplication part is the easy. Y is equals to x minus 4. This is x plus 1, x minus 2. First thing first, coefficient of x cube is positive, top right, bottom left, and then the roots. Now, this one is already factorized for you, okay? So therefore, the roots is y is equals to 0, x is negative 1, x is positive 2, x is positive 4. If the examiner will make you factorize, if the Cambridge examiner will make you factorize, that is necessary of this form, ax cube plus bx square plus cx. There is no d, there is no constant. So this is a must. But they can also already factorize it for you, multiply it out, you get this, that's good, and then make this diagram. So now 4 and 2, that is over here, and the other one is negative 1, 4, 2, and negative 1. So this is negative 1, this is 2, this is 4, this is top right, this is bottom left. So reciprocal functions, should I do it today or let's do it tomorrow along with exponential? I think let me just do it a bit. So reciprocal function is of this form. And let me first write it down. Y is equals to 1 over x. This is the inverse proportionality function. If x increases, y decreases. If x decreases, y increases. That's the first thing. If x is positive, y is positive. If x is negative, y is negative. That's the basic idea. That is something like this. So they have written a constant m. Let me just write it m over here. So this m, I'm writing y is equals to m over x, where m is a positive constant, and I can write a plus minus on the outside later on. So if I want to draw this thing, let me draw it like this. So this will be like this, and this will be like this. Now over here, this is y is equals to m over x. M is positive, and it's drawn in the first quadrant. This part of the graph is called first quadrant. This is called the third quadrant. So it goes like this. This is first, this is second, this is third, this is fourth. Let me also label it. So now over here, when we have a grid, let me just pick the grid from here. Okay. So when we have this grid over here, so this one is first quadrant. This one is second quadrant. This one is third quadrant. This one is fourth quadrant. And there is a reason for this. They label it anti-clockwise because anti-clockwise angles later on are positive angles. Right now, this is what you need. So now over here, this is in the first and the third quadrant. But if I have y is equals to negative m over x, so because of this negative sign, there is reflection in x-axis. The positive becomes negative, negative becomes positive. So now the graph would be like this. So therefore, this one is going this way, this one is going this way. Instead of first and third, this one is now second quadrant and fourth quadrant. So this is second and this is fourth quadrant. Now there is one other thing. That is the concept of asymptotes. So y is equals to 1 over x. If x is 0, 1 divided by 0 is undefined. If I give you $1, if I give no one $1, how can I divide? So just keep it for right now. Remember two very crucial things. That is this thing, the first one, and the second one. The first one is 0 divided by any number is 0. If you have 0 things, and no matter how many people are there, they won't be getting anything. That's a philosophical perspective. Any number divided by 0 is undefined. People can also write infinity, but for our purposes, it doesn't make a difference. You write infinity, you write undefined. So when x is 0, y is, let me write over here. When x is 0, y is 1 over 0, y is undefined. Similarly, if y is 0, x is 1 over y, 1 over 0, that is also undefined. That means now I have two asymptotes. This is a horizontal asymptote, asymptote, horizontal asymptote, that is y is equals to 0. And over here, there is a vertical asymptote, that is x is equals to 0. So now over here, this is not this one, that should be this one. The purple one is this. The purple one is this. This is y-axis, x is 0, y-axis, x is 0, x-axis, y is 0, x-axis, y is 0. So there are no x-intercepts. It will be bounded by these two asymptotes, this and this. This part of the curve is bounded by these two asymptotes. You want to increase the green over here, perfectly good, no issue. So these graphs, they have no x-intercepts, they have no y-intercepts. That is the basic idea. Now, what if I move it up? Y is equals to 1 over x plus 1. Y is equals to 1 over x minus 1. What if I move it up or down? So the green line will move up and down. So now the green line will be shifted up. So this is y is equals to 1 because of this. The green line will be shifted down. So this would be y is equals to -1. And then from the perspective, draw the curve. So now, since the coefficient of x is positive, that's the red curve, that goes like this. Let me draw it like this. And it goes like this. It has to stay within the asymptotes. The purple asymptote is unchanged. And let me just erase this. I'll just label y over here. Over here, again, this thing, it goes like this. It goes like this. The y, the vertical asymptote is unchanged. So the vertical asymptote is unchanged. The vertical asymptote is unchanged. Got the idea? So now the horizontal asymptote has risen up. The horizontal asymptote has gone down. And just two more graphs and we are all set for today. And then we can meet tomorrow, most likely, inshallah. So now, what if I draw y is equals to -2 over x plus 1. And y is equals to -3 over x -1. So now, first of all, just focus on that plus 1. Grab your green marker. Plus 1, let me draw it like this. This is y is equals to 1. That's because of this. Y is equals to -1. Let me draw it like this. Y equals to negative. The vertical asymptote, the y-axis, that is unchanged. This is x is 0. The vertical asymptote, that is unchanged. X is equals to 0. Let me write x is equals to 0. Let me write x is equals to 0. And now let's grab the blue one because negative will be second and fourth quadrant. So negative will be second and fourth quadrant, the blue marker, the thick one. So that is over here like this and over here. And let me make it more accurately like this. And then this one is like this and this one is like this. So that is the basic idea. I'm just looking for, I think, too many empty graphs. So sketching exponential function, we will start it tomorrow. So signing off for today. This is Mathematics with Shahab Yaqub. Take care, everyone.